My name's Alan Haig. I'm a physics teacher at Woodkirk High School. I'm going to show you an experiment, quite a simple experiment, but I'm not going to tell you what's going on. You're going to use your skills to try and deduce how I've done this particular experiment. The order of the lesson is based on solving a mystery. I first of all introduce the mystery of the Cartesian diver. I present it as such as a trick where no explanation is offered. In fact, I offer a bit of a red herring in the term of a wand. We've got a water bottle, completely full of water, except in the middle, what we have is a test tube. Now, hang on, is this working? Right, sorry, it's a bit temperamental. Okay, here we go.
Oh, I know what you've done.
All you have to do is fill up the bowl right to the top, take the test tube, half fill it with water, put your thumb over the top, turn it upside down and try and get it into the water as quick as you can, losing as little water as possible. What I want to see first of all is, can you work out how to do it? Then try and think of ways in which you would try and prove how to do it. The objective of the lesson is to get them to use their observational powers and then their explanations of science, thinking about using their understanding of science and applying it to an unfamiliar situation.
It's a magnet because when you move the thing up and down, the test tube moves at the same time with it.
Hopefully, through their powers of observation, we can think about what is causing that air bubble to change its size. Yeah, go on.
There could be a magnet inside the bottle because, you know, the thing they're using, it could be a magnet and it's attaching, so it's moving up and down when you're moving the stick.
Is it to do with the static electricity bending the water, which is making the water inside the bottle, which is making the test tube move?
Some of the theories that we've had from students most often would be something like magnetism. And the main reason for that would be that magnetism is the first non-contact force that most students are aware of. If they're thinking about, well, maybe it's not the object, maybe it's the water, static electricity can be seen as quite a good explanation. We're in the second part of the lesson now. Kids are trying out their own ideas, they're making their own diver to see if they can work it out. I've given them a few red herrings in terms of static electricity and magnets. A lot of them seem to be heading down that direction. So let's see if any of them can find out what's really going on.
It don't work. It don't work because it's in the wrong position. Now we'll try it. Oh, I got this. No, it don't work with this.
I believe this lesson could be applied for any year, from year 7 all the way up to year 11. Ideas of density and forces are used in year 7 through 8. In year 9, they start to use pressure, and it allows them to show their understanding through the Key Stage 3 topics.
Do you know when you just do that, it doesn't work even if you rub it on anything, you've got to squeeze it and it just goes down.
So squeezing it seems to make it move up and down?
Yeah.
Was I squeezing it?
Yeah.
Was I?
Yeah, you have your hand there, squeeze the bottom, that then it goes down. Sure, that doesn't do anything.
That doesn't do anything, so you think I was tricking you?
Squeeze the bottom,
So,
comes down.
you think you have an answer? Can you try and explain to me? Have a look at what's going on in the test tube. Try and explain to me how it's working. The key terms that the students should be thinking about using in terms of the explanation of what's going on will be the idea of forces, weight, pressure and density. And from this, it's quite a good overall synoptic tool to be able to see, can the students apply their full understanding of science, their ideas of forces, and apply it to this situation they have not come across before. It's not a cheat!
Nice cheat!
It's not a cheat, it's science! Density!
Yeah!
Oh. I'll be honest, I made this 5 minutes before the lesson with duct tape and a board pen and a piece of rule. It doesn't work because, as all of you know now, that in fact it's done by my scary telepathy powers.
Cool.
No, so you just squeeze the bottom.
Sorry?
Just squeeze
I squeeze the bottom, yeah. If you think about what can move in this bottle, when you press it, the only thing that can move, because liquids can't be compressed, the only thing that can be compressed is that air inside the test tube. So that compresses it. Now, then, when I squeeze it, that compresses. If there's more water in there, the overall density of this system increases, so it will start to sink.